Hi everyone, welcome back. So in this video, I'm going to do an analysis of something called an instrumentation amplifier. That's the circuit that you see on the left here. So it's basically a circuit that consists of three op amps and a series of resistors. So it has two inputs, V1 and V2, and it has a single output, Vout. And this circuit is typically used in, it's actually used in many places because it's actually a very good uh, differential amplifier, basically. All right. Now, the the circuit itself consists of two parts. All right. The first part we call the input buffer stage. That's basically covering the input voltages V1 and V2. All right, all the way to the output of that particular stage. So you have two outputs here. You have one output there. You have another output here. Right. So that's the input buffer stage, and its job is to ensure that it will help in minimizing the loading effects of this particular amplifier. The second stage, what we call a differential amplifier stage, is basically starts from R2, well, from the output of the first stage, all right, the output of the first stage, and pretty much ends at Vout, all right. So that's our second stage. Okay, that's our second stage. So our second stage is actually a differential amplifier stage, and I've already covered the derivation for the second stage in my earlier video. So you just have to click on the link, appropriate link here to get to that part. All right. So the differential amplifier stage is the next stage. So you have an input buffer stage that takes in inputs from of V1 and V2. There is in itself its own gain. It has its own gain, and then the output of that stage then goes into the differential amplifier stage again with its own gain. So you actually have a system with two gains: the input buffer stage gain and the differential amplifier stage gain. Okay. So we basically, the way we're going to analyze the circuit is we're going to just look at the input buffer stage, and I'll leave the analysis of the differential amplifier stage to the other video that I've already made. All right. So when we come to the differential amplifier stage, I'm just going to quote the equation, the final equation, and then I'll proceed from there in order to figure out what Vout is. All right. All right, so to analyze this, we can, again, because it's a two-source system, we can use superposition theorem to solve this. I'm going to use just KCL to solve it. Okay, KCL and KVL to solve it, and Ohm's law to solve it. So the first thing we got to do is, of course, again, a reminder of what are the two assumptions that we should make when we're analyzing a circuit with op amps. Number one being that all the inputs to all these three amplifiers, op amps, will have 0 amps. All right, that's number one. And number two, the voltages on the nodes of whether if it's a non-inverting and then to an inverting, it will track, right? So for example, if you look at the diagram down here, V1 will track V2 or V2 will track V1. Okay, whatever V1 is, that's what V2 is going to be. Whatever V2 is, that's what V1 is going to be. All right. Okay, so let's have a look at the second assumption first. So we're now analyzing just the input buffer stage. All right. So if we were to look at the node that is out here, right? So that means the output of the first stage before it goes to the second stage, I can label them as VA and VB. So let me label them as VA and VB. That's the two nodes top and bottom there. All right, so I'm going to call that VA and VB. So the top one is called VA and the bottom node is called VB. So effectively, VA is the output from this amplifier, op amp, and VB is the output of this amplifier. All right, so that's VA and VB. Okay, the other thing based on the second assumption about V1 and V2 here is that if this non-inverting input is a V2, Therefore, the inverting input here must also be V2. So that means this node here is going to be V2. And then similarly for the top op amp, if this is V1, then this node here is also V1. All right, so let's label that as well. All right, so I'm going to put the label on this side. Okay. All right, so now you have V1. So V1 is the if you like, the inverting node of V1, and V2 here is the inverting node of V2. All right, so they'll have the same voltage nodes. All right, and then the other thing we can look at is, based on assumption 1, there will be no currents flowing into any of these inputs. There will be no currents flowing into any of these inputs, which means if I have a current flowing down through R1, okay, if I have a current flowing down through R1, that means from VA here, it comes down to this node V1, that current will completely go to our gain and will also completely go through R1, because none will be going into the inverting terminal of the top op amp, nor will it go into the inverting terminal of the bottom op amp. So if I were to call that current as IG, then I have an IG here that will simply be across R1 here, R gain here, and R1 there. So it will go through all three. Excuse me. So to summarize, so let me just redraw that if you like, and the circuit would look like this. All right, so this is the circuit that I'm going to analyze. Okay, so let's analyze the circuit. Let's build some equations for this circuit. All right, so what sort of equations can we make? Well, again, using just Ohm's law, I can write an equation for this IG, and this IG. So I can write an equation for, 3 different equations for the same current. All right. So the first one, I'll say current through R1. All right. So that's of course is IG. So that's going to be IG equals 2. Okay, so the voltage, of course, if you have current coming down, the positive voltage is of course is pointing up, right? So so therefore it's going to be VA, the voltage, right? So it's going to be VA minus V1, right? So VA, that's the top voltage node, the top node there, minus this node here, which is V1. All right, so let's do that. So VA minus V1, all right, divided by R1. Sorry, VA minus V1. All right, so this is 1. Okay, so that's our first equation. So similarly, I can say something about the current going through our gain. Which is of course going to be IG as well, is equal to. Okay, so for our gain, well, again, so it's going to be V1 minus V2 divided by our gain, right? So that's the voltage polarity across our gain. Okay? And then finally, the current through R1 at the bottom R1, all right? The bottom R1. Okay, there's a reason why they're both called R1, because it means that they are same value, all right? Okay, so maybe I'll call this just differentiate between the top and bottom. So this one's going to be BR1, B dot R1. All right, so that's the bottom R1, and the first one is going to be TR1. That means the top R1. All right. Okay, so I have a current through the top R1 and the bottom R1. So let me just move this diagram down a bit. Okay. All right, so again, it's equal to just IG is going to be equal to, okay, so this one is going to be V2 minus VB, right? So that's the voltage polarity, minus VB, all divided by R1. Okay, so now we have the three equations for IG across the three different resistors. Okay, so now what we can do is, well, we can actually combine them already because they're all IGs. So if you want, we need to find an expression for VA and then find an expression for VB. So the idea is, once we have an expression for VA and VB, then we can apply VA and VB as input to the differential amplifier stage. So that's the whole idea. All right. Okay, so let's just continue. So let's have a look at equating. Let's have a look at getting VA, all right, in terms of V1 and V2. So I'm going to combine this equation of IG with the one that is going through our gain, all right? So equating IG for the top R1 and our gain. Okay. So we're gonna get one equation. Okay. And so it would be this being equal to this here. All right. I'm just gonna copy this. Okay. All right. So what we want to do here is we want to convert this equation into a VA equals something. All right. So I'm just going to, at the bottom here, I'm just going to continue with basically having, I just move R1 across to the other side. All right. Then I'll just have a VA minus V1 on the left. And then I have R1 divided by R gain multiplied by V1 minus V2 on the right. Okay, so let's do that first. Okay, so I'm just going to copy the previous equation. All right, so I'm going to not have, well, I'm just going to have a VA minus V1 on the left. All right, and that's going to be, R1 is going to move to the right. So therefore, it's going to be R1 divided by R gain. All right, I'll just clean this up a bit. And then this side will just simply be V1 minus V1, sorry. It will be V1 minus V2. All right. Okay. Okay, so, and then next thing to do is I just want to move this minus V1 across to the other side so that V is on itself, by itself, and then to factorize V1. All right, so let's do that. So now I will not have minus V1 anymore, so V1 will go to the other side. So then it will go to the end here. I'm going to put it at the end. So it becomes plus V1. All right. And now I'm just going to multiply R1 over R gain out of those two, basically flattening out this bracket term here, so that I can then gather V1 together. All right. So that's going to be R1 over R gain times V1. All right. Just copy this because I'm going to use it again. So times V1 minus the same term times V2. All right, so that term is gone, and then again it's plus V1. So next thing is, of course, to just gather V1 together. All right, so that I will then have the following expression. All right, so I'm going to have a, so I'm going to make V1 a common term. So then this would then be, will end up inside a bracket. So it's going to be that term. Sorry, just R1 over R gain. All right, and then plus 1. So the plus 1 part is, of course, related to this thing at the back here. All right. Okay, so that's pretty much it. Okay. So now, so that is my expression for VA. Okay. So next, I can do the same thing again for VB by equating the IG expression that is across the bottom R1 with the R gain IG. All right. So this time I'm going to just it's just going to be similar, or very, very similar. The only difference is instead of a VA minus V1 over R1, it's going to be V2 minus VB over R1. So let's just do the whole thing again. All right. Okay. So I'm going to make this to match this one here, right? So this one will be for so equating now. Let me say equating IG for bottom R1 and R gain. All right. So when we do that, so you're going to have this expression first of all. That's going to be equal to this expression here. All right, the IG term going through R gain. Okay. So just as before, we move R1 to the other side. All right. So move R1 to the other side, so it becomes V2 minus VB on the left. So it's going to be V2 minus VB on the left, and on the right it will be in brackets will be R1 divided by R gain times Z1 minus V2. All right. Okay, then once more, what we do now is we move V2 across to the other side. Now, if we multiply both sides by -1, okay, if we multiply both sides by -1, then I'll have a VB minus V2 here, and then I'll switch around. It becomes, instead of V1 minus V2, it'll be V2 minus V1. Let's just do this step by step. All right. Excuse me. So okay, so VB is no longer here. It's going to be on the other side. Sorry, negative VB is still there. It's V2 that's going to disappear. It's going to the other side. It's going to be minus V2. All right. Now we continue on. So I'm just going to expand my window here, so I can continue writing more stuff. Okay. All right. So so next I'm going to switch. Well, let me just gather first. Let me just gather the terms there. All right. All right. So before I proceed, I want to remove this negative sign in front of VB first before I do anything else. So let me expand my space here so that I can add more stuff. Positive VB here. All right. And then obviously I'm going to reverse, instead of this whole term minus V2, I'm going to get V2 minus the whole term. All right. So V2 minus all of that. So, all right. So now I've got it in the positive VB. So let's just continue. All right. So here, what I'm going to do is I'm going to obviously multiply out the expression here. So I'm going to get V2 here. I'm sorry. So I'm going to get V2 there. That's not changing. And then I'll just multiply out this and that. So R1 over R gain times V1. And then R1 over R gain times negative V2. So you're going to get this term here. All right. So I'm going to get that term there. So going to be that term there multiplied by V1. And then plus the same term multiplied by V2. So it's plus because it's negative times negative, so you get a plus there. All right. Okay, so now I can gather V2 together. All right, so I'm going to gather the V2 together. And once I do that, I think I would have the final answer. All right, so let's do that. So VB then. Okay, VB. Okay, I'm going to expand my space a bit more here. All right, so let's continue here. So now my VB also the right hand side of the equation is going to be this term. So basically this term here on the right here, I'm going to put that as I'm going to take that out. All right, so that's no more. That's no more. All right, so it'll be 1 plus that term. All right, 1 plus that term. All right. So I'm just gathering V2s here. So V2, there's a V2 there. So V2 times 1 is that, and then V2 times this is this term at the back. And then I have the remaining, which is V1. So now I have a partial equation. So I have a VA that is like this, and I have a VB that is like this. All right. So just to recap, VA and VB are these 2 points here. Yeah, these 2 points here. So those terms, VA and VB, will now feed into the differential amplifier stage, which is the stage over here. This part here is the differential the amplifier stage. So if I were to, so let's just continue the analysis. So this is now the new circuit that we're going to analyze. But the analysis of this has already been done in my other video, so you guys can check that out. So here I'm just going to say applying VA and VB to as inputs to the differential amplifier, which sometimes are called subtractor amplifier or difference amplifier, so it goes by a few names, to the differential amplifier. All right, so applying VA and VB as inputs to the differential amplifier. And the equation for differential amplifier is basically given by this. Okay, the V out is simply, so again, to see the derivation of this, please check out my other video. So that's the equation. So V out, that's this V out here, is going to be equal to R3 over R2 multiplied by VB minus VA. So what we're going to do is we're just going to substitute our VA and VB. So let me just highlight these two lines. They're not final results, so I'm going to use a different color. Let me use this color. All right. So these are not final results. It's just VA and VB, intermediate results. Okay. For just VA and VB. So therefore, I can write here that V out is going to be equal to, first of all, R3 times over R2. So I'm just going to write R3 over R2. All right. Multiplied by, okay, here's the big thing. So we have a VB, which is this guy here. So I'm going to copy that. All right, so that's our VB. I'll remove the highlight later. So that's VB, and then minus VA. Now VA, I'm going to put it in bracket because there's a minus in front of it. So minus VA. So that's this term here. Okay. Right. So let me remove the highlights. Okay. So that's just continuing. So we need to sort this out. So we have like V2 here. Say one more bracket to cover the whole thing. Right. All right. So we need to then gather together the terms. Let me expand this some more. All right. So what can we gather? Well, we can keep R3 over R2 on the outside for now. If you look at this, there is an V2 term here and a V2 term here, and a V1 term here and a V1 term here. So we can gather V2s and V1s together to simplify the equation. All right. So let's do that next. All right. So now inside the bracket. So let's have a look at V2 first. Okay. So on the first term is 1 plus R1 over R gain, right? And then it's this whole thing is minus this term here. So minus and minus becomes a plus. So therefore, this part is going to be a plus R1 over R gain times V2. All right. So R1 over R gain times V2. So let's just do it step by step. All right. So that's our V2 term. Now for our V1. Well, this is a negative R1 over R gain times V1 minus V1 and then R1 over R gain plus 1. So basically, okay, this term is now gone. So basically for V1, all right, so you have this and you have to combine with that. So it's going to be just minus and then, well, nothing's changed. It's just going to be this term here. So all right, so going to be minus that term. All right, so then I don't need this anymore. Okay. Okay, so next, just continue on to factorize V2 and V1. So we're just going to continue to factorize V2 and V1. I think I'm running out of space here, so okay, let's just see how far we can go. Okay, I'm going to shorten things up a bit. So let me do, okay, so let's just factor out V2 and V1. Okay, so what do we get? Okay, so you're going to get a, V2 1 plus R1 over R gain plus R1 over R gain. All right, so once we factor out V2, so it's going to be this term, so it's going to be plus that. So then that term disappears. All right, now on the V1 side, okay, so on the V1 side, I'm going to have a, so let's say I put V1 on the outside here. Okay, let's say I put V1 on the outside here, right? And then in brackets, so it will be this R1 over R gain plus plus the term on the right, yeah, because it's minus and then multiplied by the plus becomes the minus in the original part. All right, so I'm going to have now this term. All right, so now we have, as you can see there, actually the terms in brackets are identical for both V2 and V1, so we can then factor that out. All right, we can factor that. So that's what we're going to do next. Okay, so basically 1 plus R1 over R gain plus R1 R gain means it's 1 plus 2 R1 over R gain, correct? So that term disappears. And similarly here, I mean, I can write exactly the same way so that it leaves no doubt that they are actually the same term. Okay. All right. So again, I can further factor that out. You know, so that becomes now you have three terms now. You have a R3 over R2, right? And then the next term is going to be 1 plus 2R1 over R gain. And then finally, we're going to have a V2 minus V1. Okay? So what we have here finally is again a difference or a subtractor kind of circuit, V2 minus V1, right? So remember our original circuit is here. So it's going to be, the output is going to be V2 minus V1 and then multiplied by a few factors. All right? The first factor is 1 plus 2R1 over R gain, which if you look in our original circuit is actually the gain from the input buffer stage. All right? It's the gain from the input buffer stage because that's where R1 and R gains are located at. All right? So 1 plus 2R1 over R gain. And finally, the last term is this R3 over R2, which is basically the differential amplifier stage gain, right? That involves R3 and R2. Okay, so in order to, for example, if you want a unity buffer, you can make R3 and R2 to be the same. Then you'll just have R over R, for example. Then they'll cancel out. This becomes 1. All right. Then you can then modify R gain to whatever value you like in order to get an overall gain. Yeah, overall gain. This will be the overall gain for the instrumentation amplifier. Typically, such a device would be fabricated on a single chip, and you would have the R gain terminals. That means, this node V1 and node V2 will be taken out as a pin on a chip, where you can then plug in your own R gain, and thereby controlling the instrumentation amplifier's gain. All right. So hope you guys understand the process for analyzing an instrumentation amplifier, where the final expression is the difference multiplied by the input stage gain and then multiplied by the differential stage gain. All right. Thank you for watching. See you guys in the next video.